Although the concept of the polar vortex may seem complicated for beginners, it is essential to understand that, while it is not a catastrophic weather phenomenon like a hurricane, it can significantly impact weather conditions, causing sudden changes in forecasts. The polar vortex is, in fact, an extremely complex atmospheric formation that plays a crucial role in the global climate balance. There are two main types of polar vortices that are carefully monitored by weather experts: the stratospheric polar vortex and the tropospheric polar vortex. While their effects differ, both can lead to changes in weather conditions in Europe. What does it do in Europe? In Europe, the direct impact of the polar vortex is not as strong as it is in other parts of the world, such as North America. However, the tropospheric polar vortex has recently caused significant changes in the southern United States, with cold waves and extreme temperatures due to the arrival of polar air masses from Canada. In Europe, such events are rare, but that doesn't mean they can't also occur on our continent, especially during particularly cold periods. The polar vortex. What is it and its importance to the climate? The stratospheric polar vortex is a large area of low pressure that develops in the Arctic region, above the poles. This weather phenomenon primarily forms in the stratosphere, at altitudes ranging from 10 to 50 kilometers. It is important to emphasize that its dynamics can also affect the troposphere, the part of the atmosphere where the weather phenomena we experience daily occur. The strength and intensity of the polar vortex depend on various factors, such as wind speeds and the involved temperatures. It also affects the ability of these cold air masses to reach lower latitudes, like those in Europe. When the polar vortex is in a stable state, with the cold air mass contained within the Arctic region, the chances of cold waves breaking out southward decrease. In such cases, the weather in Europe tends to be milder, with temperatures higher than the seasonal average. However, when the polar vortex is disrupted, as in the phenomenon known as sudden stratospheric warming, cold air from the Arctic can be pushed southward, leading to a drop in temperatures, heavy snowfall, and a general decrease in atmospheric pressure. The weather in our seas is another crucial element in understanding the atmospheric dynamics of February. Sea surface temperatures in the Mediterranean are often above the seasonal average, and this excess heat represents a significant energy source for the formation of severe weather systems. When a cold air mass collides with the warm waters of the Mediterranean, disturbances can arise that can be violent, leading to severe thunderstorms, cloud storms, and sometimes even Mediterranean hurricanes. These hurricanes, also known as metacanes, when they reach strengths comparable to tropical hurricanes, tend to form mainly in the winter months. The temperature fluctuations between the cold air and the warm sea create a fertile ground for extreme weather phenomena, with storms and heavy rainfall affecting different areas of the Mediterranean. When these hurricanes reach their peak, weather conditions can become particularly violent, causing significant damage.